Good morning, everybody. My name is Troy Conklin. I am with Broadcom, and we're going to be going through the upcoming launch of the HPE Gen 7 64 gig Ready SN8700B directors and blades, and the SN6700B fiber channel switch, and some updated Gen 6 switches that run with FOSS 9.0. Of course, with me today is Matt Lynch from HPE Switch Engineering. And from my team helping answer questions in the question manager is Zafar Irfan, which, and I think most of you probably know all of us, and especially Matt, and probably secondarily me. So we'll get rolling through here. So got a little bit of legal disclaimer from both HPE and Broadcom, standard issue stuff. So the agenda that we're going to be going through is I'm going to start off with the Condor 5 ASIC, which is what all of these products are built off of. So I'll give you some of the specs on the ASIC and what it can do, and then I'll run through the 3 new Gen 7 switches, the 2 directors, the X78, the X7, which we call the X78 and X74, which is the SN8700B in HPE speak. I'll try to use the HPE terminology, but my brain wants to default to the Brocade Broadcom terminology, but I'll do my best to make sure I get it in your speak. The SN6700, which we call the G720. So if you hear those terms around, that's the map. And then we have we're doing an SN6600B refresh and an SN6650B refresh, and I'll talk about those. We've got some secure optics that you've heard about a little bit. Probably we'll give you some details on those, and then I'll go through FOSS 9.0 and what's included in that, and then we'll wrap it up with SANNav 2.1, which is the newest release of our management application. And if you do have questions, make sure you do pop them into the question manager, and we'll get those answers as we go. And we'll do some live questions at the end as well. And if something pops into the question manager that sounds like something we need to stop and talk about, then I'm perfectly happy to do that too. And Zafar and Matt, you can just jump on in if you need to. So let's talk a little bit about the Condor 5 ASIC. So this is our now this is gonna sound a little different than what you've heard from us in the past. So I'm going to start out with a Gen 7 variant of the Condor 5 ASIC, and it'll make more sense in a little bit, but this is what you would normally consider the Condor 5 ASIC. So this is our Gen 7. So it is, I mean, the short answer is this enables our 64 gig speeds, which I'll get to that a little bit more as well, but it gives us in addition to doubling the speed, it also gives us about a 50% improvement in latency compared to the Condor 4 and 4 Plus ASICs when we're supporting NVMe over fiber channel workloads. So the switching latency is 460 nanoseconds, which is quite a bit faster than it was with Gen 4. So they made some pretty good improvements in there. So that's a very good thing. We've got some I/O insight enhancements in here for learning scale and learning capabilities of the ASIC itself. And the ASIC itself is actually monitoring for violations in I/O latency threshold. So it's doing it all in chip, which makes it very, very fast, and it scales across everything. You don't have to worry about that because it's just built into every single port. We've also got more buffers per ASIC over the current generation, the Condor 4 ASIC. So that gives us a lot more flexibility and reach in doing things over distance. The ASIC itself, the Gen 7 variant of the Condor 5 ASIC supports, of course, 64, 32, 16, and 8 gig speeds, which is all normal. You know, our ASICs always support 4 speeds, but there's also 10 gig fiber channel in there as well. So if somebody has one of the Metro links where it's a 10 gig ring or anything like that, then we can also run at 10 gig itself. So you're using the entire bandwidth of the wavelength that people usually pay pretty good money for. So that's kind of the 5th speed that we can support with this ASIC. There are 64 ports on the ASIC, and it supports the normal port types, you know, E, EX, F, M, and D ports. And most of you should remember what those are. The E is, of course, a port that connects 2 switches. EX is a routing port from one switch to another. So when you're doing routed fabrics, which doesn't happen in every single at every single customer, but there are lots of customers that use that extensively. F ports, of course, are for devices. M are mirror ports. So I'm not really going to talk about that today, but you can look up information on that. You can always ask us questions over email if you want to. And D is a diagnostic port to help test things out, test the link in the cable and the SFPs and drive high levels of traffic over it without disrupting your SAN to make sure the physical infrastructure is stable. Actually a very, very, very good thing to use, especially greenfield fresh installs, to make sure everything has gotten installed correctly. Which, as most of you might probably have experienced, it doesn't always get installed quite right, and some of the cables can be a little funny at first. The ASIC also supports increased encryption, decryption, and decompression capacity over the Condor 4 Gen 6 ASIC. It is feature compatible with the Gen 5 and Gen 6 Condor ASICs, so you can connect, one of these newer switches to one of the older switches, and the encryption compression will work, and everything else will work. It just downshifts things it needs to downshift so that everything still runs like everything will still function. It just won't function at the new version of things. But it will downshift itself so that it can still work. The Condor 5 Gen 7 ASIC is used in the Director core blades, the CR64 blades, and also the FC 64-48 Gen 7 port blade. And so that's our 64 gig capable 48 port Gen 7 port blade. And we'll get into more details on all these things, of course. And then as well as the SN6700B, which is what we call the G720 switch. There's also a Condor 5 Gen 6 variant as opposed to what we just talked about as the Gen 7 variant. And this is something new that you've never seen us do before, but I'll explain why we're doing that in a little bit, but just give you the rundown on the ASIC itself. So this is Condor 5 based, but it's a slightly different ASIC that supports Gen 6 features and functionality. So functionally, it's the same as a Condor 4 Gen 6 ASICs that we've been doing. I'm not going to get too much into why we had to do this, but just the short answer is the people that were fabbing our chips are not going to be fabbing our chips anymore, and so we had to we couldn't just roll that fab to someplace else, so we ended up taking our Condor 5 Gen 7 ASIC and doing some modifications to it to create this one and have it at the fab that we're currently using for continuity of supply. And this ASIC does all the Gen 6 speeds, so 3216, of course the extra 10, 8, and 4 gig speeds. This also has 64 ports, same port types. It's feature compatible with the Gen 5 and Gen 6 Condor ASICs, just like and that's what we've been doing for pretty much ever. They're always backwards compatible like that. And this Condor 5 Gen 6 ASIC is used in the FC32 X7-48 Gen 6 port blade, and as well as the SN6700B, which is we call the G620. This is a new version of that switch, and then the SN6650B, which is a new version of the G630, which is our name for it. And we'll go through all this stuff, just kind of giving you a high-level update from an ASIC point of view. Okay, so now we're going to run through the B series SN8700B director switch. And this, if you've been through one of our trainings before, especially when we did the Gen 6 release with the director, this is all going to look very, very, very similar. It's nothing completely departing from our normal method of how we have been releasing directors and switches, so this is all going to look very, very similar. And so this isn't anything going to be scary or brand new or anything like that, so that's good. So of course we're doing two Gen 7 director chassis. They are based on the X6 chassis design, which is what you're happily selling in the field right now. It's the same frame, same power supplies and fans as well. So those things are all, it's the exact same ones, no difference there. There is an updated control processor, so a CPX7 control processor blades, and then of course we need the new Gen 7 core routing blades to support the newer features and the newer speeds. And the chassis is going to be sold as airflow neutral. So I'm not going to get too much into this too, but if you have questions, please do ask, and of course Matt can help answer some of this stuff when I can't. What that means is that you buy the empty chassis, and by empty I mean empty. It's got the CPs and the cores, but that's it. And you have to choose what you want in there, which is good because then if you say, well, I need a reverse airflow director, well, you can. You just buy the reverse airflow power supplies and fans, plug them in, and you're good. Or if you want the normal airflow, you just buy the normal airflow power supplies and fans. So you can, depending on what your end user customer needs, you just buy the right pieces and just it gets all put together, and it just goes in whichever airflow direction you need. There are 4 Condor 5 based port blades. There are 2 48-port Gen 7 fiber channel port blades, and you can get those with either 32 gig short wavelength SFPs in them or 32 gig long wavelength SFPs in them. Those are the 2 flavors. And then there are 2 new 48-port Gen 6 fiber channel port blades you can get those with 32 gig short wave or 32 gig long wave. So that's the kind of the new port blades that are going to be going into there. We are going to be consolidating the director offerings into the Gen 7 director family. So the current Gen 6 blades can go into a field upgraded Gen 7 director chassis. So if somebody has a Gen 6 chassis, they can field upgrade that into a Gen 7 chassis, and their current port blades will continue to function in the new Gen 7 chassis. So they're not going to have to rip and replace blades and things like that. The net of that is to do that upgrade, you do have to replace the core routing blades, which of course is disruptive, but it's of course way less disruptive than if you had to rip out the chassis and put in a brand new chassis. So that is something that we can support, where they would. So it's a little bit more details to that, and I think we might have a slide on that down in the presentation, but it's kind of the big part is pulling out the Gen 6 core routing blades and putting in the Gen 7 core routing blades. There's more steps to it than that, but that's kind of the main physical portion of that. The Gen 7 directors do come with integrated routing, ISL trunking, fabric vision, extended fabric Vicon cup in the base switch, so you're going to get those every single time, which makes it pretty easy. There's not a lot of other options you're going to have to really think about. You can just you buy the switch and you pretty much get all the features. And then this director does come with FOSS 90X with web tools. Now, I think we're going to touch on the web tools as well, but we'll come to that in a little bit. So this chart, I'm not going to go through this whole chart, this port blade differentiation by functionality, but this is a great chart to have so you can tell what the difference is between the various blades, what their compatibility is, and what their capabilities are. This is a kind of a fresh chart from us. So as of October 2020, this is accurate. Things can change over time too, so if you ever have any questions, of course, please do feel free to ask. But this shows that if you have let me get the little laser pointer going here. If you have a current FC32-48 port blade, which is the Condor 4 based port blade that you get in your X6 chassis right now, that can go in the current Gen 6 chassis, the X6, which of course is what you've seen so far, but that is also supported in the Gen 7 chassis. So you can put that in the newer chassis, or in an upgrade if you upgrade a Gen 6 to a Gen 7 chassis, it works just fine there. That blade does have 4 gig speed support, and we've called that out because of over on the right, and I'll get to that in a little bit, but it has all the normal speed supports you would expect. In this case, that blade for metrics, it only has SCSI metrics because of its capability of the ASIC that enables that. So that blade specifically has SCSI metrics, but it can't do NVMe metrics because of the Condor 4 ASIC in there. Now, if we bumped over to the FC32-64 port blade, when we built that blade, we built it with a Condor 4 Plus ASIC, and this was right when NVMe was really starting to get gets a lot of traction, and we could see the demand coming. So we modified the ASIC a little bit so that it could do NVMe metrics. So that's why that one can do the NVMe metrics, and of course it can be used in either the Gen 6, the X6 chassis, or the new X7 chassis that we're talking about today. Now, so those two columns are current blades that you know and love already, and then the right two columns are the new blades that are part of this launch. So now, in this case, these two new blades, they only work in the Gen 7 chassis. They don't go into the X6 chassis that is what's in the field right now. Now, if you were to upgrade an X6 to an X7 chassis, of course now it's an X7, so you can put those blades in. But these two new blades are not backwards compatible to the old chassis because you've already got blades. These are just kind of the newer replacements for the older blades, even though the older blades still work. So the FC64-48 port blade, which is the Gen 7 blade, that does not support the 4 gig speeds because it's a 64 gig capable blade. So I'm not going to go through all the rest of these. If anybody has any questions, please let me know. It looks like there's a question. Didn't you mean 64 gig shortwave? I'm not sure where that was, which slide that was asked on, but Matt got an answer to that. So if you're curious, you can go take a look at that. So let's see. Let's go to the next slide. Okay, so the SN8700B, which we call the X7 director family, if you look at that picture, from that picture, except for where it actually has X7 on the label, which is down here at the very bottom, beyond that, there's no way to tell that whether this is an X7 or an X6 director because it's the exact same chassis, same sheet metal. You know, it's just different blades in the same chassis. So, we're doing the 8-slot chassis on top, the 4-slot chassis on the bottom. The power supplies and fans, as I mentioned before, are the same power supplies and fans. What's changed is they have fiddled with the bezel a little bit, so they've kind of gone a little bit more minimalistic on this, although it's got a little bit difficult to tell. And it does support the X7, the 8700B does support 64 gig line rate device ports. The iScale ports are at a Gen 7 data rate. And some other, there's a backplane stiffener, but the stuff you can't see. And then it's got a cable comb on the bottom, and there are some other security enhancements in there that came out of the for the control processor. So another director support matrix. The chassis shells are essentially the same. The functionality of a chassis is really differentiated by the core routing blade. So if you have a Gen 6 core routing blade, it's an X6. If you have a Gen 7 core routing blade, it's an X7. Essentially, is what it kind of comes down to. And as we talked about a little bit, you can disruptively upgrade from an X6 director to a Gen 7 80. You can go from an 8600B to an 8700B in the field if you'd like to. There's got to swap some hardware, and there's some FOSS and FPGA updates you need to do as well. But this kind of gives you what works where. Okay. So the X6 director upgrade to a Gen 7. So our investment protection that we're doing with these two chassis. So it does leverage, as we've talked about a couple times now, it does leverage existing chassis and components. It does, to do the upgrade, it does require FOSS 9.0 or later. Kind of the way, and shouldn't be a surprise. Whenever we have a new generation of hardware, so Gen 6, Gen 7, Gen 5, whatever it is, it always causes our FOSS to jump to the next major revision. So if you're running anything that's Gen 7, it's going to require FOSS 9.0 or later. FOSS 8.x doesn't understand Gen 7 hardware, so you can't load 8x on a Gen 7 piece of hardware. And that shouldn't be a surprise. That's what we've always done. Of course, a Gen 6 piece of hardware running 8x, which is what it launched with, will be upgradable to 9.0. So we always support the hardware with the current and then one newer version of FOSS. So kind of the high-level part of the steps is replace the core routing blades. If you want to add some Gen 7 blades or continue using your Gen 6 blades that are already in your chassis, that's just either way is fine, and you can mix and match those two once you've done the first parts of the upgrade. And then there is a step-by-step document available on the customer support portal that you can get that goes through, each step of what you need to do and to be able to plan it all out. Okay. So a little bit more detail on the upgrade. This upgrade, if you're going to upgrade your chassis from an X6 to an X6 Gen 6 to a Gen 7 chassis, it is non-reversible. It only goes forward. You cannot go backwards. So if you're not sure, you might want to wait and make sure until you are sure. First thing you need to do, of course, is upgrade to FOSS 9.0, which is step 1. And then there is a non-reversible FPGA update that it needs to be done on the CP blades. So it turns a Gen 6 CP blade, into a Gen 7 CP blade. And if you're really paying attention, you'll notice that we don't call, when you go through this update, we don't call it a CP7, which is what you would get if you ordered a Gen 7 chassis fresh from the factory. It's going to be called the CP7. We call this a CP6 because it has been field upgraded to be able to differentiate between an upgraded chassis versus a brand new chassis. And then once you've done this FPGA update on the CP blade, it will not allow downgrades to 8X again. So you're at 9.0 and you have to stay at 9.0. There's no way to downgrade it once you've done this FPGA update as part of the chassis upgrade procedure. And then at that point, then you would need to swap out your 2 core blades from Gen 6 to Gen 7. And then there are some PID changes that are required when it gets updated, so it goes into unified 10-bit addressing on the Gen 7, and I'm not going to really go into that today, but you can get some more information on that on the various manuals, of course, or send us some questions. And then a little table that shows if here's the X6 chassis, and we shipped that starting with 8.0, but it's going to have some version of 8X from the factory on it. It's got a CPX6 CP blade in there. And then when you do the upgrade from an X6 to a Gen 7, it has to be running FOSS 9. It's got the CPX6 Plus that has gotten that FPGA firmware update that we talked about. And then if you bought the Gen 7 from the chassis, from the factory, it's going to come with 9.0 from the factory, and it's going to have a CPX7 control processor blade in there. But I've also got the switch types for the 4 slot and the 8 slot, so 165, 166 for those of you that really care about this. This of course shows up in the switch show command on the CLI. And then the one difference between an upgraded X6 to Gen 7 chassis versus buying one from the factory is the secure boot feature that isn't supported on an upgraded chassis, but it is supported on a chassis out of the factory. It has to do with the CPU that's on there. The one in the X6 chassis doesn't have the support, but the X7 does. Okay. So a chart of part numbers for the new SKUs for the chassis. So we've got the 2 new 8-slot and 4-slot chassis. Power supplies and fans are added separately, and so those are going to have their own part numbers for each of those, and you can always look all that stuff up the normal way you do. The blades, we've got the two core blades that determine the speed, and then there are the 2 flavors of the 64 gig ready blade that's going to currently come with 32 gig optics, because 64 gig optics aren't quite ready for the market yet, unfortunately. And then there's the 2 blades that are 32 gig capable blades that come with 32 gig optics as well. And then there are some ICL pod kits for these are some of the very few. There's not a lot of options with the directors anymore. We've kind of simplified it down so you don't have to have a lot of permutations you have to think about and worry about. But if you did want to do ICLs, then there are pod ICL license kits for connecting either this first one is to connect between 2 Gen 7 chassis, and the second one is to connect between a Gen 7 and an older Gen 6 chassis, because that only supports 32 gigs, so you need to use the correct ICL kit to connect depending on what your 2 chassis that you're connecting are. And there's also the a shortwave transceiver kit as well. So now I'm going to move over to the new pizza box switch, the SN6700B, and in Broadcom speak we call that the G720. So it's the replacement for the current G620. So it's a it's a fiber channel switch. It's got the Gen 7 ASIC. It's got 56 ports of 64 gig capable in a 1U form factor. It's going to come with 24 ports in the base switch. So if you want to buy the kind of quote-unquote smallest version of that, you can get it with 24 ports, and then you can add 8-port pods, and you can do 4 of those now. So we've made the pods a little bit more flexible as well over time. So if you want to add 8 more ports, you can go from 24 to 32 to 40 to 48 to 56. So makes it a little bit more flexible and as well as cost flexible for selling and dealing with your customers. Of course, it supports all the normal port types, and this does come with FOSS 9.0 with web tools. It's a full speed, full bandwidth switch, so it can run full line rate on all the ports all the time. It does support fiber channel, and it does require secure SFPs in the ports, and of course that'll support all the speeds you would normally expect. 816, 3264 plus the 10. And as we talked about the ASIC, it has a 460 nanosecond port-to-port latency, which also includes FEC, which was one of the pieces that they've improved to get us down to the 460 now. And it does have in-flight encryption and compression. We've got 128 gigs of encryption and decryption bandwidth, and 128 gigs of compression bandwidth, and 64 gigs of decompression bandwidth. And both encryption and compression are enabled and supported. You can do both of those at the same time if you want, of course. On the back side, it has 2 hot swappable redundant power supply. It's a power supply fan pack in the back, so it's got 2 of those back there. So if one of them fails, the switch can run on a single. And you can also get this switch in either airflow, depending on what your customer wants. Most people want the normal airflow that we've always had, but there's always somebody that has either a telco design or a slightly different hot aisle, cold aisle layout than what we normally see, and so they need a reversed airflow to be able to handle the switch. So we can do, with you guys, we can do either airflow direction. And this switch comes with the integrated routing, trunking, fabric vision, extended fabric PyCon cup included on the base switch as well. And of course, FOSS 9X with the new web tools, which I'll talk about in a little bit as well. So here's a little bit of it's a close-up view of the SN6700B. So you got this front view, the rear view shows the 2 fan power supply packs back here. So you've got the one on the right. Let's see if I can. Yeah, so you got the supply on the left and the supply on the right, power switch, fans, everything all is integrated in there. And then we got a kind of a close-up view of the front of the switch. One thing to do be aware of, in red here it says console port mini USB. So there really isn't much space left on these guys. We've got these guys packed pretty tight, so there wasn't space for another RJ45 port on this switch. So what they decided to do is, so you've got your RJ45 for your hooking up to your management network. It does have a regular USB port, so you can use a USB stick to do firmware downloads or support saves to transfer those big files back and forth if you need to. And for management, instead of a serial port with a regular RJ45, which is kind of how we used to do it, where we put a mini USB port on there, and I believe it does come with a little USB to serial port converter that comes with the switch, so you can plug into that thing if you needed to use the serial port. And of course the status and power LED, and the SFP ports with their LEDs just like normal. Over here on the right, there are 8 SFP-DD ports. Now these are double density ports. You may have heard about these already. They are getting used in other. We're seeing these kick up in all sorts of other different places, and we're starting to use them as well now. previously in the G620 or the G630, our previous switches that you saw right now, we used QSFPs over here, but what we're seeing is that QSFPs at the Gen 7 data rates just it doesn't seem to be going that direction. So it looks like people are going with these double density ports. So the SFP-DD SFPs aren't on the market yet, unfortunately, from the SFP vendors. So at this point, you can put a regular SFP into those 8 ports, and it works just like you would expect with all the other ports that are on here. But down the road, the intention is that once the SFP-DDs actually come to market, we'll be able to put those in there and give you 8 more ports. But that's going to be a future. I see a question about, does the G720 support 4 gig speeds? It does not, because our products always support 4 speeds, so it does 64, 32, 16, and 8. So 8 gig is the fastest, is the slowest speed that the new Gen 7 products can support, and that's kind of, it's always been those, the 4 main speeds as you split them in half, as you go drop down in products. So Gen 6 switches supported 32, 16, 8, and 4, but didn't support 2. And then, the generation before that did support 2 gig at the low end. Okay, some part numbers for the SN6700B. So you can get this, you can get the switch in 2 different flavors. The first is with, well, basically it's the switch in which airflow direction do you want. So it comes with 24 ports active with 32 gig SFPs for now, and then you can also get it in the reverse airflow flavor, and then there is a port upgrade kit that comes with SFPs and the pod license to install to add more ports to your switch if you'd like. So those are the kind of the 3 new SKUs that are coming along with this switch. So so we've gone through the 3 new Gen 7 switches, the 2 new directors and the 1 new switch for now. Of course, we always, as you know, with Broadcom Brocade, we've always had 3 different pizza box switches, with the small, medium, and large, and what we've just talked about was the medium-sized switch. And we will be having the small and the large switch will be popping out in later releases. Just this first time around, 2 directors and 1 switch was plenty to bite off to get through all the quals and all the work that has to get done. So the other ones will be following along later. But now, as part of this, we're doing this Gen 6 switch refresh that we've started to talk about a little bit of the SN6700B and SN6650B. So now I'm going to kind of go through that and how that is all working. So we're refreshing the 2 switches. So in Brocade lingo, it's the G620 and the G630 are the 2 switches that are getting refreshed. And as I mentioned before, there's a supply issue with our current Condor 4 Plus ASICs. So we needed to move off of those ASICs sooner than we normally would have liked. So we're doing a Condor 5 ASIC, but it's a Gen 6 version of the ASIC. So it's the same features, speed, and everything else as the existing switches, but with just slightly different ASIC in there to help with our supply problem. The FRUs, the power supplies and fans, are going to be the same between the 2 versions of the product, so that there's no change there. And of course, it's kind of part of the Gen 7 role because of the actual ASIC that's in there. In this will support either secure optics or Brocade branded non-secure optics that you've been selling for up till now. We'll talk about the optics in a while later, but of course these do come with FOSS 9.0 with the new web tools in it because it does have the newer ASIC. I see a question in the chat window, and if you want to throw those into the question answer window, it'll be a little bit easier to track those. But will G720 have long wave with ranges longer than 10 kilometers? Yeah, you can throw a Gen 6, a 32 gig optic into the Gen 7 switch, so you can get the various vendors that do the longer ranges, the extended long wave, or the CWDM kind of things. So those are supported. Those will be supported in here in the G720 as well, and the directors. And I think we'll go through a little bit of that too in a little bit. But so some of the differences, if we look at the for the SN6600B. So if you look at the SN6600B, if we call the one that you've seen and been using it for a while now in the field, if we call that the V1 and call this new one that we're now talking about the V2, so we'll go through some of the differences. The switch type does change, so you are able to tell from the switch type which flavor of switch you're looking at. The current SN6600B has a Condor 4 Gen 6 ASIC in it, and the SN6600B V2 is going to have a Condor 5 Gen 6 ASIC in it. The minimum FOS level is different, so the current switch that you're used to, it can run FOS 8 and will be able to run FOS 9 as well, of course. The new version of the 6600 will only be able to run FOS 9X. It won't be able to downgrade to FOS 8. So do keep that in mind, because some customers get a little bit funny about mixing their FOS versions, even though it's fine, but they just kind of have this thing about they always want all the same FOS versions. So if they were to buy a new version of the 6600B, it's going to come with 9.0, and that's it. You can't downgrade that to 8. It will refuse. You can't force that at all. Now, speaking of 4 gig support that we were just talking about with the G720, so with 4 gig speed support, the SN6600B, this is one of the few differences between the two platforms. But the 6600B does support 4 gig support for devices and for switch-to-switch. The 6600B V2 is only going to support F ports to host and target at 4 gigs. It's not going to support ISLs to a 4 gig switch. That was one of the things that had to get dropped off, unfortunately, but that is where that is. The new switch, some of the things that you gain, though, is you do gain some license protection, secure EEPROM, and secure boot. So it has a lot more anti-counterfeiting protection than the older version of the 6600B. Just, as we've learned things and things that get rolled into FOS, and rolled into hardware, there's just more protection in there for all of us. In the 6600B, it does have QSFP ports. In the original version, there is an LED for each of the 4 ports inside the QSFP, and in the 6600B V2, they've moved that to one LED with different blinking patterns just to make that a little bit simpler. In this case, the front of the chassis is slightly different, so there is a slight physical difference that if you really see one side by side, you will notice that there's a little bit of a difference in there. But with the newer flavor of chassis, it does give a little bit better signal integrity and airflow, which is why they did that. And then, of course, the other difference is the serial console port on the original 6600B is an RJ45 connector, and in the 6600B V2, it's a mini USB connector. And the accessory kit does include the RJ45 to mini USB cable and adapter, so you've got what you need in the box. So now kind of the same thing, but talking about the 6650B V1 versus V2. Of course, the switch type's different, ASIC's different. This is all kind of the same spiel, but different pieces of platform, different pieces of hardware. So all this is pretty much all the same as with the last one. So a few different differences, but nothing earth-shattering in here. The 4 gig support is kind of the same as the other one, so that is a little something that kind of goes away a little bit. Hopefully shouldn't be too big of a deal for you, but it is one of the differences. Okay. So part numbers for the 6600B V2 and 6650B V2. So you'll be able to get the 6600 with as a 24 ports, but no SFPs. But you can also get it as with 24 integrated SFPs. And then for that's the 6600 and this 6600. And then for the 6600, we are rolling out and moving over to doing pod kits. So you can get the pod license and the optics. So if you buy a 12-port pod, you get 12 ports of optics with it. You don't have to order those separately and remember to order those separately, which sometimes can end up with a problem if you only ordered one or the other, and it's not really useful without the other half of the of the kit. So we're starting to bundle those together into a single kit where you get the license key and the actual physical SFPs together. So you don't have to worry about that part so much. And for the 6650B, we're not quite to the pod kits with that guy yet, but that will be rolling out later. It's just a step-by-step with this. But do notice the note here at the bottom, the existing a la carte pod kits and SFPs are still supported for the V2 switches. We're just adding this pod kit bundle in there as well.
Hey, Troy, I just want to note one thing before you move on.
Yeah.
So you'll note that the V1 and V2 switches have exactly the same name that is being done by both Broadcom and HPE. You'll note in the documentation that when we talk about the switches, they use the switch type along with the name of the switch to designate the version 1 to version 2. The V1 and V2 in these slides are just to show you the difference between the two of them.
Thank you very much. Okay, so now you've heard me mention secure optics a few times now, so let's go in and talk about that and what exactly that is so that you can understand what we're doing there and why. So secure 7 products. So the security measures are implemented across. It's built into the system and into the optics themselves and FOSS and the hardware. So it's built in throughout the whole infrastructure. And there is authentication and software algorithms to detect and make sure that the optics being used are actual brocade optics and not third-party counterfeit optics. And that sounds kind of funny saying that, but we have seen way more cases than I would have ever expected of people building SFPs that, and we've seen them with brocade labels on them. We've even seen them with HPE labels on them, and they're not from us. They're not from you, and they're not from us. And somebody is trying to sell these they're basically knockoff optics, and sometimes they work, and most of the times they don't work very well, but they're selling them for cheap, and so people think, oh yeah, hey look, that's a really good price. I'm going to buy those and use those. And on our older switches, the level of protection wasn't as great as and we've been ramping that up over time, but we would see these optics fail in the field and causing customer satisfaction issues. And some of them are kind of easy to spot physically, and some of them they've even gotten the sheet metal pretty well correct. But if you open it up, the components inside are not so good. So it's been causing both of us quite a bit of issues. So we've gone over to these secure optics to make sure that the customers are using the optics that we know will work and we know we can fully support and deal with, and not have all these other problems that were being caused. Now, in Gen 5 and Gen 6 switches with equivalent support for non-secure optics, so the SN8700B 32 gig SAN extension blade and the Brocade 7810 do require some FOSS versions to use the secure or non-secure optics. So if you're going to have some secure optics in there, you do need to make sure your FOSS versions are a little bit newer. Than those are they're not super new versions, but they are newer on the market and available from HPE. So you do need to make sure you use those if you're going to be popping some of these newer optics in there. There's some extra protection in those blades that we stumbled across, and so we've got that worked out though. Okay, so some of this HPE Secure Optics SKUs that are now going to be out there. There are 32 gig secure optics, so there's a shortwave and a long wave. There are also some 16 gig secure optics, so a shortwave 1 pack, a long wave 10 kilometer, and an extended long wave 25 kilometer at 16 gig. And then of course there are, to support those 10 gig speeds that we need every once in a while, there is a shortwave and a long wave versions of the 10 gig. And then we also have QSFPs that are secure for, this first one is for inter-chassis links, and then a 100-meter secure transceiver as well for QSFPs at 32 gig for the Gen 6 products. So, Matt, is there anything else on the secure optics? I know you and I have been dealing with it for quite a while now, but is there anything else that we need to touch on in here, you think?
Yeah, I was answering your question. Did you touch on the optic support with those two refresh switches? Which optics were going to be supported? I just wanted to point, I guess, on those two switches, on the 6600B and the 6650B, that they're going to require the secure optics or Brocade branded non-secure optics, which HPE does not directly sell. We do include it in our current integrated switches and blades, so you can move them over, but you can't directly buy those non-secure optics from HPE. The current 16 and 32 gig HPE optics will not work in the new V2 version of the 6600B or the 6650B.
Thank you. I felt like I was missing. I'd forgotten something in there. Thank you for that. And one other thing. So beyond the caveat that we talked about with the SX6 and the 7810, so if you leave that out, so if you have a secure optic, you can put that in one of the older switches, and the older switch doesn't know how to check, so it doesn't care. So that will be backwards compatible in that manner. So if you end up with a secure optic and you put it in, say, a 6600B V1 that's currently in the field, it'll light up and it'll fire it up and use it just fine, and there's no problem. And it actually, between a 16 gig secure SFP like this get that pointer back. This guy here, the 16 gig shortwave secure optic, the difference between that optic and a regular 16 gig non-secure optic is basically the only thing that's different is the security features. So from everything else, it's exactly the same optic. So if you pop that into a SN6600 original, it'll fire up and run just fine. You don't have that. It's backwards compatible in that manner.
All right, we do have one question on the secure optics here. So would the secure optics feature work with embedded CWDM such as smart optics? And I believe the way to answer that is the smart optics are going to work with the Gen 7. The smart optics CWDM are going to work with the Gen 7, but they're not going to be secure optics.
So let's kind of take a high-level look at the HPE B Series Gen 6 and Gen 7 portfolio, just so you kind of get an overview of what you've got all out there. So at the Gen 6 level, you've got these, you've got the 3600B, which is the small guy. You've got the 6600B, the medium-sized switch, and the 6650B, which is the big switch. So you've got the pictures of them up here. So you've got that at the Gen 6 level. At the Gen 7 with this release, we've got the SN6700B, which is the mid-size switch. So that you've got a new Gen 7 mid-size switch here. And then at the director level, the 4-slot and the 8-slot chassis, you've been selling the 32 gig version, or what we call the X6 version of those two directors. And what we're talking about today and what you're going to be launching here shortly is the SN8700B, which is the Gen 7 version of the two directors. And then you've got the director blades that we've been talking about, the 32 gig versions and the 64 gig versions that we've gone through. So I always like to see the picture of it to see what goes where. So the big difference is going from the current mid-range switch to the newer mid-range switch. Okay, so now I'm going to move into Fabric OS 9.0 and some of the features and functionality that are new and enabled in the newer version of FOSS. So of course 9.0 has to have new platform support, so it's got the Gen 7 directors and blades and the SN8700B switch. It also has support for the refreshed 6600B and 6650B switches. Some of the new Fabric OS features is there's a fabric congestion notifications built into FOSS 9.0, and we'll go through and talk about most of this stuff too, but I'm just kind of give you the high-level spin of it. We've got a new feature called Traffic Optimizer. There's I/O Insight Flow Learning and Streaming, which has been improved over the FOSS 8.0, what we've been doing with that. The new FOSS features of web tools, so that's going to be, you're going to like that one. So I'll touch on that in a little while. There are some new security features, and some the way we're doing licensing is improved and a little bit different in FOSS 9.0. Some feature enhancements. Well, of course, we're always trying to make things better as best we can. So maps and fabric performance impact monitoring have been enhanced. Some of the RAS infrastructure has been improved. Zoning, and there are, of course, various customer RFEs that get rolled into every version. So in the FOSS 9.0 platform support realm, so we've got the directors and the switch that we've talked about already, the 8700B and the 6700B mid-range switch, and then the refreshed 6600B and 6650 based on the Gen 6 Condor 5 ASIC. So FOSS 9.0 is also supported on all Gen 6 platforms. So the SN8600B, the 6650B V1, 6600B V1, the SN3600B, and the SX6 extension blade. Deprecated platforms in FOSS 9 is anything Gen 5, which is essentially 16 gig. Those cannot run FOSS 9. They can only run, they were launched with FOSS 7, and they can be run, they're of course supported on FOSS 8, but they cannot be upgraded to FOSS 9. So some of the new features and stuff that we're going to be talking about with FOSS, those don't go back and get back into the Gen 5 platforms. So that's everything Gen 5, director switches, embedded, extension, all that stuff. If it's Gen 5, it can't run FOSS 9. Interoperability, FOSS 9.0 supports ePort interoperability with FOSS 8.1 and 8.2, which is all current. If you're running something a little older than if you're running an 8.0, you need to upgrade, because that's some very, very old code, and it's definitely need to be upgraded for bug fixes and security fixes and all sorts of other things. If you have a switch, a 5 gig switch, if you have a Gen 5 switch running FOSS 7.4 or even a Gen 4 switch that had got an upgrade to 7.4, it is interoperable with FOSS 9 through fiber channel routing. You do have another option. If you have one of the smaller switches that can be an access gateway, you can flip it into access gateway mode and run it that way, and it would be interoperable with FOSS 9 with that method as well. And that's kind of the same way we've done things for the last few large releases, so this shouldn't be too much of a surprise for anybody. So now I'm going to give you an overview of fabric congestion notifications. So if you haven't heard of this before, it's kind of a newer thing in the fiber channel specs community. So they've been working on how do we let people know if there's congestion happening in the fabric, and let them know quicker than waiting for some sort of a SCSI timeout or IOs to start failing or anything like that. So what we're doing is we're using our Fabric Vision portion of FOSS to monitor and detect for SAN fabric congestion conditions proactively, and then if we can send notifications, then we can facilitate other devices, ourselves included, and other devices, storage and servers, to be to self-mitigate this and kind of self-heal the fabric without requiring administrator to do something on the command line or change cables or do something physical like that. If we can adjust things ourselves, working with, of course, storage and servers, then that makes everybody's life much, much better. So a FOSS 9.0 fabric will allow people to register if their device is participating, and the maps feature within FOSS will trigger fabric performance impact notifications, or FPINs, out to devices and to other switches as well. And the Gen 7 hardware will also signal congestion to connected devices, so as another method, an even faster method. And we'll talk about this stuff here just as we get forward. So the purpose of the fabric notification and signaling is to let people know about congestion as fast as we can, and so that gives the hardware it allows the hardware to be able to react to things at hardware and software speeds as opposed to you know, human speeds, which can take a while, especially if it's late at night. And then it allows some corrective actions to be taken. And of course, the things will be noted will be in the logs for people, for those of us humans to look at later and check out and see what was going on. But try to be able to mitigate those things at the time. For this to work, of course, the end devices have to support this communication, and it's up to each. It's up to the HPA vendors and the drivers that are in the servers and the storage arrays to be able to do this. But you can't do anything if the fabric doesn't support it. So that's kind of the big first step. And so that's what we're enabling with FOSS 9.0. And this is all part of the T11 spec. So this communication and information is it's all an agreed upon response recovery mechanism that's fully documented and supported in the T11 spec. So it's not something that's just a brocade kind of thing. It's just a T11 thing that everybody is able to do. It's just a question of development time and when things are going to get released and how people are who's going to take advantage of what portions of this. Now there are hardware link-to-link signals that we'll talk about, and there is also software level fabric-wide notifications. So there's a couple different ways that they can do this. Just kind of depends on which hardware you're talking about and what actually is happening. So with FOSS 9.0, the switch can alert, if a device is registered for FPINs, we can alert them about things like in-device congestion, generally Cobra subscription and credits, all kind of things. So if you've got a slow drain device, we can tell the device, hey, you're being a slow drain device. You either need to stop requesting so much, slow down on your reads, so that if it's, let's say it's a host, so that you're not pulling in so much data that you're causing a slow drain spot in the fabric. But you can at least let them know, because they may not know. So that gives them information to be able to react upon. We can also send FPINs for link integrity, so CRCs and interword transfer. The problems between the frames, which generally indicates a physical layer issue, which could cause frames to get dropped and have to get retransmitted. So if the link is still up, but it's kind of sick, we can actually let people know about that. And then we can also let people know if we detected a SCSI command frame drop. So we can tell the device that, hey, a frame got dropped, and so they can deal with that now instead of waiting for the full SCSI timeout, which is usually 60 seconds, to be able to detect it themselves. So we can actually let them know faster to allow faster recovery. And these kind of 3 data types were already available using MAPS alerts in FPI and SDDQ features and the frame viewer, but this is a targeted way to communicate this to registered end devices, so that they can decide if they want to take action or not. And they're not required to. They were just giving them the information, and then it's up to them to decide what they want to do and how they want to handle it. So the end device congestion data type. So let's talk about what that exactly means. So this is a kind of oversubscription or credit stall. So an end device congestion can back up the fabric, which can cause fabric performance issues, not just at their own port. So it can be things like if you have a host that sends out a whole bunch of different large read commands down to their storage. When the storage starts dumping that back, especially if you have multiple storage arrays on one server, you can ask for way more data than it can absorb at any one time. So you can cause a whole flood of data to come back faster than it can deal with. So if it's a 16 gig device, but it sends, in this example, you've got like 10 different read requests to a 32 gig device, he's going to dump back data. He's going to dump data into the SAN at 32 gig speeds, but the host can only absorb it at 16 gig speed. So he's only half speed compared to what it's going to be coming in. So it can cause a large backup of data trying to flow through the fabric and back up into the storage array as well. So we can send a notification down up to the host itself to let it know that what's going on and that he's causing this kind of something like this is being seen. And so you might want to do something a little different, like maybe not send so many read requests in such a bulk. There are lots of different options that that the device itself could have. With FOS9, it is possible to send a hardware level signal. If it's a Gen 7 switch, it can send a very low level primitive up to the device, so you don't even have to wait for a BB credit. It's not a frame, so it's like one of the low level signaling primitives. So it's like a NOS or an EL or an LR, one of those kinds of things where you can send it up when it's a known special signal, and we can to let the device know that something bad is going on without having to wait for a credit. Because if you're having a credit stall because it's just swamped, it's going to be a while before you can get a frame into the queue to get up to the device for it to see it. So that's a super fast way to do that. But there's also a software notification which is sent more like a frame that's basically telling the device you should probably throttle back and kind of slow down. And then there's also a software notification that would go to the target on the other end saying there's a host that can't keep up. You might want to slow down too. So and these aren't demands; they are suggestions. Just we're trying to send them the information so that they can make a more informed decision of what they think they need to do. There's also a end device link integrity data type that can be sent. So if we're seeing CRCs or intertransmit words issues, we can let people know without causing a full path failover. So this is where we would call, I don't know if you've heard the phrase before, if you have a sick but not dead. So if you've got a link that's kind of getting bad, but it's still working, but it would be nice if the host would avoid that path or use a different HBA or something, just kind of push some of its load somewhere else because its overall performance is going to improve rather than trying to push data down a link that's causing lots of retries. So with FOS9.0, you can send a software-only base notification to notify the end devices, both local and remote, that there's a link integrity issue and that they might want to move over to a good path with their using their MPIO process on the server, the software on the server to deal with that and avoid some problems that they're experiencing right now. But the problems aren't bad enough where the link is gone, because that's easy to detect and to deal with. But it's still there. It's just you just don't want to take that freeway. You want to move over to the other freeway because it's moving way faster. There's also a SCSI command delivery problem that we can tell people about. So if we know a SCSI command frame got dropped, we can alert on that and let people know that it's gotten dropped. And so you can actually go ahead and start the retry. Start the SCSI retry procedure right now. You don't have to wait for your full 60-second timeout. You can do it now, kind of thing. So then it's up to the device what it does with the information we're sending in, of course. But it does allow faster recovery of these kinds of things. So that's kind of the high level of the FPIN features that are now available in FOS9. Now, if you do remember that some of these we talked about some that are hardware-based that require a Gen 7 hardware of a switch to be able to do the hardware-based ones, but many of these are FOS-based. So even if you have a Gen 6 switch or a Gen 6 director, if you upgrade to FOS9, you get the software-based alerts are enabled by the FOS. So even if it's on a Gen 6 platform, you still get those features. So that's simply a feature of FOS, not of the hardware. So as always, some things are enabled by hardware and some things are enabled by the FOS itself, which can be run on various flavors of hardware. So I'm going to go through Traffic Optimizer. So this is an automated placement of traffic flows to performance groups over ISLs. So at this point, this is only for ISLs, so switch-to-switch connections, but it's a new way of further segregating traffic when you're transiting an ISL to try to keep slow traffic from blocking up faster traffic is kind of what it comes down to. This does require the Gen 7 hardware on either end of the link because it's a lot of this feature is enabled by the ASIC itself. So kind of the short answer is it takes flows in each performance group by the identified target speed. So if it's an 8 gig device or 16 gig device or 32 gig device, those guys will get bucketed together so that you have everybody kind of driving the same speed over the same link. Because it's never fun when you have an 8 gig stream flowing over with another stream that's 32 gig and causing traffic backups. So this also helps us provide optimal buffer allocation. And then each of the performance groups, each of the PGs, includes a predetermined number of virtual channels. So each speed-based PG uses 4 virtual channels, and then 7 VCs are reserved for priority-based PGs, which is in the future that'll be even more configurable. Currently in FOSS 9.0, the feature is not user configurable. It kind of is what it is as we kind of get this started, and then as we learn more, we'll probably tweak it a little bit, and then eventually make it user configurable as well if we think that would be helpful, and as we find use cases where that is helpful. And then in the future, we might be able to do things like NVMe flows go to a particular, that anything NVMe goes into its own flow, and so it's not running in the same flows as SCSI, because NVMe tends to flow a lot faster just naturally than the regular SCSI stuff does. So the way it's been working up till now with the legacy traffic flow ISL distribution is traffic is put into a specific virtual channel based on a calculation which involves the traffic's destination address and source port placement. So it uses the PIDs to map to, or kind of hash to, a VC of which VC it's going to flow over. And we do have a number of VCs, so that does help quite a bit. But what we're seeing is this can still result in traffic being sent and received by devices who are operating at different speeds, which can cause congestion. But the slower devices can basically slow down the faster devices. So if you have a new 32 gig storage and a host, but you've also got an old 8 gig host trying to ask for things, the 8 gig host traffic on the freeway can basically slow down the 32 gig flows that actually want to flow a lot faster. So we have done pretty good about that, but we've determined that there are some more improvements that we can make to make everything flow faster. So kind of visually, you still only got one ISL trunk between these two chassis, but if we have like a modern disk with running at 32 gig, and then you've got some sort of a legacy server running at 8 gig, say, to tape, and then you've got some other really modern server that's going to be doing 64 gig to one of your 3-part SSD arrays that's going to really be screaming. We want to kind of put those guys in their own lanes so that they can run as fast as they possibly can. So that's kind of the overview. But do remember, this is still just it's one big ISL trunk that's still physically there, and at this point this all happens kind of magically in the background, and there's nothing for you to have to configure. It'll just be able to divide stuff up, and it'll give us some more benefit and some more speed between the switches on the ISLs. It doesn't do anything, of course, on the device ports and on the host ports, and it doesn't do anything on the storage ports. Those are a different matter. So the performance group details. So there are currently 5 PGs defined, 3 based on speed and 2 based on priority. So the default PG we're calling that PG1, and if this is getting used, then it's going to be speeds between 0 up to 16 gig. And then PG2 would be essentially be at 32 gig speed, and then PG3 would be 64 gig speed. And then we still do have the low priority QoS and the high priority QoS. In kind of the old style of talking about it, this default PG would probably be the medium priority QoS. And if you haven't done QoS before, everything has been running in the medium priority QoS at this point. So the default PG provides, of course, legacy behavior, which we don't want to. We always want to keep that stable, so everything works the way it has been working, unless we're going to make it a little bit better. if a flow can't be, if they can't figure out how to classify something reasonably, they'll just leave it in the default PG, so it won't be any worse than it normally would have been. But the speed-based PGs are supported on FCR and long-distance links. So we're no longer going to collapse all the flows into a single virtual channel over a long-distance link. So that's going to give us some good benefits over those long-distance links, which can be a little bit more sensitive. And of course, when you collapse everything into a single VC, you've only got a single-lane freeway, single-lane highway running there. So if you've got somebody running slow, everybody else has to back up and basically slow down to that speed. And we do provide backward compatibility for existing QoS and SDDQ mechanisms. And I don't believe I'm talking about SDDQ today, but that's slow drain device quarantine. If you need more information on that, pull up the admin guide or the previous trainings, and we have lots of detail about what that exactly is and how we automatically quarantine a device flow that we determine to be slow drain off on his own frontage road, so he can run slow as he wants, but everybody else can get back up to speed. Okay, so now I'm switching topics now over to analytics. So the analytics transition, the key analytic feature we have is zero disruption, automatic learning, and then visibility into the storage ports and host ports. We want it to be scalable, and it needs to be integrated with a management platform. The way we had been doing this kind of up till now is hopefully you've heard of our AMP product, and it was a device, sort of like a switch, but a little bit different, that would kind of sit off to the side. It would plug into the other switches, and it would gather, and the switches would send it lots of statistical data, and so it could look at what's going on and the flows that are happening. It wasn't in line to the traffic, so it wasn't in the way, but it would gather all this data and be able to tell you, it would be able to give you SCSI transfer times and how long between your SCSI command to the transfer ready to the SCSI status, and it can give you a lot of information, which is really, really good, especially for the big fabrics, because it gets very difficult. It can get very difficult in a large, complex fabric to determine that you've got a device that's running slow or that's causing problems for other people, and to try to find that root cause, it can be very difficult, simply because it's a complex fabric. So we had kind of come out with this analytics monitoring platform, or the AMP, in that time frame, and from everything we've learned from that, we've taken that knowledge and we've folded it into the Gen 7 ASIC. So the ASIC itself now has a lot of this stuff built into it. So SAN telemetry monitoring, so because it's built into the ASIC now, it's built into our switches. It's got flow-based performance metrics across the fabric, and it will enable advanced traffic shaping by mapping similar traffic flows together. So that's part of, the traffic optimizer uses some of this as well to say, well, I can tell this is a 16 gig flow, so I'm going to put all the 16 gig guys all together because they're all running kind of the same speed, and that's great. But I don't want them blocking up my 32 gig streams, and I don't want those guys blocking up my 64 gig streams once those start flowing too. So we're doing a lot of investment in this area to, try to make things easier, faster, better, but also make it so that it's not relying on the admin to have to know all this stuff and to be looking at this stuff. We want this to be just automatic, so it happens, and it can tell you what's going on, and it can even react for you, and at least for the get the easiest stuff first, and help you out, and let you know what it's doing, of course, so that you can decide if there's something else that needs to be done from an administrator point of view. So the IO Insight feature is kind of AMP was kind of the first foray into that, and we did that as an external box. So we had AMP, and it has a ton of features that it can do, and we folded some of those features into the Gen 6 ASIC, and so there was a few things in there that we could do with Gen 6, like SCSI read-write response latency, and then with some of the platforms we had NVMe read-write response latency, but there's a bunch of things we couldn't do with Gen 6. Of course, there's VM Insight flow monitoring in there too, but there was a bunch of things we couldn't do with the Gen 6 with 8.2 because FOSS couldn't do that. With FOSS 9, we are able to add a couple more things just simply from FOSS, even though because it's not reliant upon the ASIC itself. So, automatic initiator target flow learning is something we've been able to add with FOSS 9.0 on Gen 6. And then telemetry streaming into SANNAV is something we've been able to add from the Gen 6 with FOSS 9. And of course, those are things that we've added on that are things that AMP has always been able to do, but we've been able to get it into the switch. So we're getting more and more functionality into the switch. And then with Gen 7, once we get to FOSS 9.1, then we didn't do this with 9.0 yet, and we didn't do it with 9.0 because 9.0 is really focused on getting the hardware up and out, and then this is a big add-on of a lot of work in the software realm. So we've been focused on bringing the platforms to market, and then with FOSS 9.1, we're going to be able to add a lot of these, pretty much almost all the features that AMP could do will be folded into the Gen 7 switches with FOSS 9.1. So we're going to be able to do this stuff just natively in the fabric. And so you don't have to buy an amp. You don't have to do. There's a bunch of other things you just don't have to do. It just comes with it. It just comes along with the platform. You get it for basically for free. So that's kind of what we're doing with the IO Insight set of features. And so we're continuing to push forward on that to try to give you more, not just data. We want to give you more information and tell you what's going on and what we suggest what needs to be done. And if there's something that we can react to help with right now, then we'll do that and let you know what we did, and trying to make that all easier and better as fast as we can. So I'm going to jump over to the new web tools. So with FOSS 9.0, we've got a brand new fully rebuilt version of web tools. If you've seen hopefully, and you should have seen our SANNAV by now. So it's the same look and feel as SANNAV, and where's my little thing? The biggest thing that I want you to see in here is it doesn't have Java anymore. Finally, we've gotten away from the Java and all the. Yeah, no, seriously, it's been a pain for all of us for many years, but we've finally been able to rebuild rebuild the web tool, so it doesn't require Java on your laptop. It just fires up. It's HTML5. It'll run in a browser. So that's kind of when they finally told us this, they basically got a standing ovation because it's been a pain for us as well. But it's got the same UI and look and feel as SANNAV, so it's got a very consistent flow. So it's in some cases it's actually a little difficult to tell if you're in SANNAV versus web tools because the flow and the look is very much consistent. It's really nice. They've done a really good job with that. With FOSS 9.0, it does support most of the existing web tools features, looking at the switch hardware and logical view, switch overview, port settings, zoning, access gateway settings. There are some things in legacy web tools that have been deprecated. So the FCIP performance graph has been deprecated, and the SSH client has been deprecated from within the web tools. And we're calling them both web tools. It's just there's the newer web tools in 9.0 and the older legacy web tools in 8X and back. Okay, so I'm going to go through some of the security features that are in this release. So some of the FOSS 9 hardware security features, so these are enabled by the newer switches. So we are able to do secure boot now. So the hardware, the control processor does do more in-depth validation of the integrity of the boot image at U-boot and Linux. So this helps to protect against tampering of hardware and boot code, and it's supported on the 8700, the 6700, and then the V2 version of the 6650 and the 6600. So the newer, it's the Condor 5, but it's the Gen 6 flavor of it, but it's supported on there too. So that's picked up in those newer hardware platforms. And secure boot is defined in the UEFI. So it's basically keep people from trying to sideload stuff onto the switch. And if there's something bad in there that we don't recognize, that the switch isn't going to boot. So it's going to keep everybody protected. Some of the software security enhancements, OpenSSL version 1.1.1 with TLS v1.3 support. the factory is loading self-signed switch certificates, so that's going to make bootstrapping secure protocols a little bit easier. Then you can put your own certificates in there, of course, as well if you want. But having a self-signed in there to start with helps you get going a little bit easier, actually quite a bit easier. There's a new maintenance account for frequently used troubleshooting commands. We're trying to move everyone away from using the Linux root account simply because you can do very bad things to yourself in there. So we're trying to create this maintenance account. So the commands that we used to have to use, especially those of you in level 3 support and level 4 support, would have to drop into root sometimes to be able to do some of the commands that we would need. Sometimes we would be our support would be asking you guys for that to do those kinds of things. So we're trying to figure out what are those things that we use the root account for and move them into the maintenance account. So that should be, if you can't do what you need an admin, theoretically you can drop to maintenance mode, the maintenance login, and get to the things that you need. And hopefully we don't have to use root, simply because it is so dangerous to be in there because you can do very, very bad things to yourself. Some other security enhancements, FCSP2 compliant DHChap with Emulix and QLogic HBAs to verify that the HBA logging in is the HBA it's supposed to be for those that are very security conscious. Usually that's ends up being maybe banks and definitely the dark government sites. Another thing in here is a mandatory change of the default account passwords upon first login. And interesting side note is you guys were the ones that first started that. So you guys were all pushing me to get engineering to start doing that, and so we started doing that for some of your products specifically, and now it's become mandatory across the whole product line. So the first time if you remember, when you log into a Brocade switch the first time, in the past, it's suggested that you change the passwords, but it's not forcing you. So you can leave the default, admin login with the password, and you can leave it there if you want. Moving forward, it's not gonna let you leave it there. You're gonna have to assign a password, which is actually good for improving security, making sure the customers are actually assigning passwords to the different accounts, so you don't have something with a default password floating around where somebody can just try the default password that's available on Google and possibly get into your switch. So that's going to help secure everyone's fabrics a little better. There's a login idle session timeout enhancement, just kind of a small thing, and then it does support Windows 2016 Active Directory support. Okay, so some security OSS package updates. So there's some versions here for you to look at. I'm not going to go through all of this. We've been continuing to move our versions forward so that it's staying away from known issues, and it's the newest, most secure and hardened versions of the things that are really important to keeping our gear safe. So a little bit more about the maintenance account and role additions. So I kind of went through this already a little bit, but basically we want this to be the replacement for root, so that you don't need root. You don't need to be able to have. You don't need to have root, or need. But I think eventually what they want to do is they want to take root out completely, just for fully protecting ourselves. But it's going to take a while to get there because there's going to be things once in a while where we need root to be able to do some funky command or something like that. But that is the goal, and it's the control and monitor with. You're going to have root-like privileges for debugging, but the access to this is going to be restricted to the console and SSH interfaces to try to keep it as protected as possible. There's going to be FOSS commands, of course, available in there, additional debug commands. And then some of the debug commands that were things that you had to drop to root for, were like blade port map. So there's going to be a service exec command to allow you to run those kinds of things. So it's almost like a way to get into that sort of a shell to get to those commands that we were using, that we were needing to get to root for. And of course, the target audience for this is Brocade authorized support personnel. So it's our support and probably you guys level 3 and 4 to be able to do these much more advanced commands to do our debugging that we have to do every once in a while. But when you do need it, you really need it. Most of the time, they'll support save, of course, this should be all that we need, and that's what we're always targeting for. Now, the forced password change. So with FOSS 9.0, and it's also watching for if you try to change the password back, like for admin, if you try to change the password back to password, it'll actually detect that you've picked a default password, and it's gonna let you it's gonna tell you that you've done that to make sure you know, and then to make sure that's it's state aware. So that was, some people would quote unquote change the password, but it would still be password, and so it's not really helping their security at all. And then of course it's going to monitor all these things. And one of the things that pushed this was there's a new, it's not new anymore, but if there's now an existing California law which came up into play this year. I think so, yeah. But it's a law that actually requires us to force a password change. So if you're upgrading from FOSS 8 to FOSS 9, and a default password is present, it's going to actually block the upgrade and force you to go change that password before you are allowed to do the upgrade. So it's kind of keeping an eye out for those kinds of things to make sure people don't still end up with default passwords running in their fabrics. Idle session timeout for SSH. So this allows us to terminate inactive SSH sessions that have just been sitting there for a long time. Sometimes that can happen if your client just bombs out and it leaves the session. From the switch's point of view, the session is still open. You just aren't saying anything. So it's nice to have that set to like 10 minutes or whatever it is, so that it'll actually close the session down. To be able to do that without you having to go in and have to go clean up sessions yourself by hand, which is doable. It's totally doable in their command sets to do that, but it's a little bit annoying when that does happen. Okay, so now I'm going to shift gears into licensing. So this is a little bit of a change for you. So this definitely going to want to be pay attention to this part, and Matt can talk about some more about how this is going to function from your website side. But so for the Gen 7 Director and the SN6600 licenses, the factory is going to come installed with the Enterprise bundle. So you're going to basically have all of your feature licenses up front, which is nice. You don't have to really worry about that. The pods and the ICL pods still are going to be licenses to add, so you're still going to have licenses for those, but there's not going to be as many permutations of licenses that you're going to have to think about and try to deal with the customer and then order and do all that good stuff. There's a new license version that we're using in the Gen 7 platforms. So we call it version 4. You really honestly don't care that it's a version 4, but it is a 2048-bit with strong encryption. And the big thing is this bullet right here. These licenses are going to be XML formatted certificate files, not a key string. So up until now, all of our licenses that you've seen have been, they used to be kind of short, but they've been a very long character string, alphanumeric, that you could just copy and paste into the license add command at the CLI or into the web tools or wherever. But with FOSS 9, it's going to be a license file. So it's an XML file, not just a key string. So it's going to be a little bit different. You're going to have to be able to do the upload, and we'll get into this a little bit more in detail, but it's for more protection of the licenses, because we do see, and this of course is to help counteract the counterfeiters that are out there trying to buy the cheap switch and then install, basically trying to hack the system and install license keys and then sell them for more money and taking money out of your pocket and our pockets. So, and then these licenses are also locked to a switch node to prevent somebody from trying to do any kind of worldwide name spoofing to try to be able to do the same thing. The counterfeit license protection, part of FOSS is it detects repeated failures of the license add operation with 24 hours. And if you So it will detect that and alert people on that one. So, and this isn't like, you've tried it 4 times and it fails. It's actually a pretty good count where it's going to, if somebody's going to hit these kinds of detections, they're doing something that is wrong. They're doing stuff they should not be doing. They're using a script and trying to do something bad. If they actually do push past the warnings and everything that we're going to give them and keep trying, doing crazy stuff and trying things on there, the switch is going to shut itself down, and it's going to be, it's not quite bricked, but it's basically bricked. It's going to have to be RMA'd. There's nothing you can do about the switch at that point, and it's going to have to come back to us. And the counterfeit license protection is in Gen 6 and Gen 7 switches. And I believe it started with 821 FOSS. So we're continuing to enhance that to give all of us more protection. And there are some CLI command changes that are going to be part of the software licensing. So kind of going through the license type by switch platform, it kind of depends when the platform came out, so that we're going to have kind of a mix of how this is going to work for a little while, unfortunately, but this kind of is what it is. So with the Gen 6 switches, which is the G610 and the original G620 and the original G630, it'll still take the license string. With the G620 V2 and the G630 V2, the SN6700 and SN6650, those are going to require the XML files because they have a slightly newer platform under the hood. The 7810, which you haven't really seen very much because you haven't quite launched that yet, and the X6 directors, those are going to take license strings, but the newer SN6700, the G720, and the new SN8700 is going to require the XML files. So it's going to be a bit of a mix, and it's going to, of course, the field's going to have bolt switches for a long time, as we all know. So it's going to be, you're going to be seeing both versions, and all of the systems should give you the proper license type for the platform that you're installing it on. So it should give you if it's a platform that needs a string, it should give you the string. If it's a platform that needs a little file, then it should give you the XML file. So the counterfeit license protection. So a little more details on that. All the license information, of course, is collected in a support save. We try to get everything we might need in a support save, and we continue to improve that, of course. But CLP will disable FOSS after 50 invalid license adds within 24 hours. So to be able to do 50, you're doing something wrong. You're doing something a little bit naughty if you're going to hit the number, that kind of number. We do have a warning at 25. We'll throw a warning RAS log. At 40, we'll throw a critical RAS log, and if they hit 50, the thing is going to be gone. You're going to have to RMA the switch. And this is for a 24-hour period. So if nothing happens for 24 hours, the whole timer and counter is reset. So it's not a lifetime. You only get 50. It's 50 within 24 hours. So it's for those of us that aren't trying anything like this. That's getting into the illegal realm. This shouldn't cause us any kind of problems at all. Because there's been times when I've pasted the wrong one in or whatever, and 3 or 4 or 5 tries, it's not going to say anything. It doesn't care. But if you get to the 25, 40, or 50, then you're going to start seeing things. If you've triggered the CLP, you're going to have to, they'll have to call into you, and then you'll have to call over to the Brocade support folks to try to get a special reactivation code. And if for some reason that was to fail, the only option at that point is to RMA the switch. And then part of this counterfeit license protection is for the SN3700B. You can't downgrade those switches below 8.2 because that's where we were seeing the vast majority of counterfeit licenses in the field, of people buying a cheap switch and then basically adding pod licenses and adding enterprise bundles and then selling them, and neither you nor us getting the money that was actually owed. So once somebody has upgraded past up to 8.2, then they can't go backwards because because we don't want them downgrading and then finding, trying to add licenses and doing those kinds of things and then trying to do an upgrade again. So it's just all part of that protection. So some CLI licensing command changes. So I guess I'll start with the deprecated. So the old commands that you've been using for many, many years now, actually many years, license add, license remove, license show, license ID show, license slot config, license port. Those commands are all being deprecated, and there's going to be a new command with a single command called license, and with a structure under it with different flags to do different things. So you can do a license install. In this case, you can do a license install and add a license key string with the dash key, or you can do a license install to add the XML file. You have to specify the host IP and protocol, kind of like when you're doing a support save or a firmware download. There's also, of course, the license dash remove, a license dash show, and a license dash release and reserve for doing ports if you're doing dynamic ports on demand. But yeah, so that's if you want to install a string, you got the string method there, and if you want to install one of the new XML files, you've got to give it the different bits and pieces. But it looks a little bit daunting right there, but it's the same thing that you do right now for firmware downloads or for support saves. So it's not anything different than that. It's just pointed at the server where the XML file lives and have the switch download it for you. Okay, that's it for licensing. Matt or Zafar, is there anything we need to touch on here, or any questions that have come in that we need to pause for, or are we doing okay?
I think we've got all the questions answered in the question session.
Okay, cool. So now I'm going to move into kind of a more detailed information on maps and FPI. So talk about what these kinds of things, the enhancements that have gone into here. So FPI, of course, is Fabric Performance Impact Monitoring. So some of the enhancements is congestion due to oversubscription. We're monitoring for that. We're also some of the FPI thresholds are user configurable to just for the environment that you're in, and then some of the FPI alerts are able to display affected all the way down to the virtual channel that's being affected as well, not just the link. So we're able to give you a more fine-grained information. We also have added some features to simplify maps operation, so you can pause monitoring of an entire switch. So if you know this could be useful for support, and definitely would be useful for PS and those kind of folks that go on site and do things. So if you know you're going to be doing maintenance and you don't really want the switch flipping out and throwing all sorts of maps alerts because you're pulling a power supply and you're pulling SPs and you're doing work, you can actually tell it just pause everything for a second here. Let me do my job, and then turn everything back on so you don't get a whole flood of all sorts of different alerts into the system that you were basically expecting because you were doing some maintenance. There's now also global action configurable of quiet time, so you can configure that at the global level instead of having to do it at the local level. So that's going to make life a little bit easier for those of you that have used that nice little feature. And then there's also some additional temperature monitoring, and we're also monitoring the temperature sensors inside the power supplies as well. So a few different enhancements in there to make things a little bit, trying to keep an eye on things a little bit better. So I'm going to talk a little bit, because we're in the kind of the FPI zone. I'm going to talk about what's the difference between oversubscription versus credit stall. So oversubscription is basically where there's more traffic trying to come in than the bandwidth is available on the link. So that's like, so if you're oversubscribed here, you're a 16 gig device and you're hooked to a 32 gig fabric and a 32 gig array, and you start doing reads, the data the storage starts flowing the data out at 32 gig rates. It flows through the fabric, but then it hits the server at 16 gig, so now it can only drain in there at half the speed. So you're essentially oversubscribed. A slow drain or a credit stall, which aka credit stall, is a little different because in this case, if you notice, all the devices are 32 gigs, so theoretically it should be able to flow through at full speed, but for some reason there's something going on. Let's say, it could be a read or a write on either. It could be a problem at either end, but there's something going on with the device where it's not able to, even though the link is the right speed, it's not able to absorb that data at the link speed that it's coming in. So it's not returning the credits to get more frames, and so it's causing the credit stall is causing it to look like a slow drain device. That's kind of the difference between those two guys. So for the pausing and restarting maps, so we've kind of talked about this a little bit, but if you want to be able to do that, you can. This is an enhancement to be able to do it at a global level, so to make it a little bit better for manageability and not get so swamped with RAS logs that are coming in because you're working. Somebody's working actually on the switch doing something active that they expect to see all these things. So we've added support to pause and restart all the rules within a larger context, so you can do all the switch rules or the port rules or the SFP rules or the circuit rules and the whole thing, and just kind of pause all of those while you're doing work in that realm. And there is a RAS log. There's also a RAS log notification that is available that can remind the user that it's paused. And so basically, once every 24 hours, they can say, hey, by the way, you paused all the switch RAS logs. You might want to go take a look at that. So just to remind the users that something has been paused, so that they can go, oh my gosh, I forgot to unpause that, and go take care of it and let it get things flowing like normal and start getting their alerts. Okay, for the system temperature monitoring overview, so there's a state-based monitoring system called System Temp, and it's to monitor the temperature of the Gen 7 hardware, and this monitoring aligns with the switch's thermal policy. There is a bad temp monitoring system that's still used for Gen 6, but it's not going to be used with Gen 7 anymore. They're going to use this new System Temp. But there are 3 valid states. So there's healthy, and there's a marginal out of range, and then in that case, you have about 30 minutes to take corrective action, and there's a critical out of range, and there's 2 minutes until the switch is going to shut itself down. So that means, generally it means for the critical out of range, something has gotten very, very hot, and it needs, whatever it is, somebody has somehow blocked the air intake, and so the switch is heating up, and it's going to shut itself off to protect itself so nothing very bad happens to the hardware. So that's not something you should see hardly ever, if ever, but it is built in there now, so that it's kind of a little more self-protection. There is marginal SFP monitoring overview to look for marginal SFPs that go into the marginal state. And that can, lots of different things can move an SFP into marginal state. It could be temperature, current, power. So, and then of course that monitoring system rolls that up into the overall switch status. So we're trying to improve how we're doing that monitoring. Some infrastructure enhancements in there. The Linux kernel. Every time we do a big release like that, we go through and make sure we have the latest and the best versions of everything. So the Linux kernel has been updated. So that has helped improve supportability, reliability, and security. There are some RAS enhancements. So we have reduced the firmware package size. So I actually bumped across this. Somebody just asked me this yesterday or the day before. And so the packages, we've reduced some of the package sizes, which will help improve, download time and then installation time. So that has made our FOSS images a little bit smaller than they were, which is actually nice because they had gotten kind of on the big side. And then there is a single command to reset the customer switch configuration to the Brocade default. Now, I'm not going to go into that too much right now, but if you do use that, do notice that I said Brocade default and not HPE default. So it will not put your switch back to as it came from the factory for HPE. It's going to put it back to the Brocade default. So there are some more steps you would have to do if you use that to put it back into the defaults that come with HPE switches. So just a little note of be careful right there. But it is nice to be able to reset stuff back, because if you don't know what somebody has fiddled with, you can blow everything away and start over from scratch. And another thing that some of you might appreciate is you're no longer required, with FOSS9, you're no longer required to use the quote-unquote special Brocade branded USB drives to be able to do firmware downloads and support saves. You can use generic SFPs. We've tested 3 different brands or models, and that, of course, will continue to expand over time, and those are documented in the release notes and then the user guides. But so you can use just a regular USB stick. You don't have to use our special USB stick anymore with FOSS9. And also there is FOSS EULA enforcement. So that's something that's been coming. We've been doing that for a little while with FOSS 8, but that's continuing to get tightened up. So the end user license agreement is in there. So if you're going to upgrade, you have to accept the EULA as part of the upgrade. So that's definitely getting a little bit stronger over time. I'm running a little short on time, so I'm just going to try to get through the rest of these guys quickly. Some FOSS 9.0 zoning enhancements. There is a fabric-wide zoning transaction lock. So that's if you've got doesn't even have to be a larger fabric, but if you've got a decent-sized fabric and multiple people trying to do zoning from different switches inside a fabric or different ingress points. So if you've got somebody in SANNAV trying to do zoning and somebody in a CLI and somebody in web tools trying to do zoning, we need a fabric-wide transaction lock to make sure that they don't trump on each other, or we can decide who takes precedence and who goes in, so we don't end up with crazy end results. And we've also increased the zoning transaction database to 4 megs for all the switch platforms that can run 9.x. And then the zoning configuration is saved in sorted order. We had seen some problems where if different switches had different orders, it could actually cause the switch to think there's a zoning mismatch, even though if you sorted it was the same, but it had ended up out of order. So they're just saving it sorted so that gets rid of that problem that has happened in the past. There are some other enhancements in here. In the platform zone, this is actually one of yours. So this is something that came in through you guys that I helped work, and we got it into the FOSS, and now it's actually fully baked in there as kind of mainstream. We'd had it in there earlier, kind of quietly and mostly for you guys, but that is fully baked in there now. There's some improvements in FICON. There's some ClearLink support that's been enhanced, and SNMP has got some more users and some other things that have gone in there. So there's some other enhancements that have gone in, of course. So I'm going to do a quick FOSS summary of Gen 7 versus Gen 6. So if you're running FOSS 9.x and you've got a Gen 6 and Gen 7, so secure boot doesn't happen on existing Gen 6 platforms. On the 2 new V2 platforms, the 6600 and 6650, that does have secure boot because it has a little bit newer CPU in there, and of course Gen 7 has secure boot. The license certificates, the XML files only are on the newer switches. The older existing switches that you know and love right now, those will stay as license strings. A unified 10-bit port addressing mode, that is going to be for all the new Gen 7 switches. I didn't really talk about that very much. If you have questions, read up about it and let us know. I'm happy to answer any questions. There just isn't enough time and 2 hours to go through everything that we've got in here. This would take, going through all of this would be like 10 or 12 hours probably to go through it in real detail. Traffic optimizer exists only in Gen 7. Congestion signaling is only in Gen 7. The new web tools is across the board. That's a FOSS-based thing. So once you've upgraded to 9.0, you get away from the old Java that makes us insane and get the new HTML5 with no Java requirements at all. IO Insight and VM Insight are yeses. And then you'd want to look back at that slide that gives you a little more detail than just these big animal picture boxes. So that's all the FOSS. So any quick questions on FOSS? I've got about 10 minutes left to run through SANNAV. There's not too many SANNAV slides, but
yeah, we got 2. So one of them is there documentation about the temperature triggers for the different states? And I The best I can think of would be the maps guide for the default policies and maps for the trip
Yeah,
triggering.
that's where I would go look first as well. If, for whoever was asking that, if that isn't answering what you need, you're always free to send me an email, but you could also send Matt an email. But yeah, we can figure that out if you have a more specific question on that. It's never a problem.
And then the other one is, when does the rides logs entries get reset in FOS9? That one I don't know.
What do you mean by reset?
I think it's when the buffer
Oh, how
flips
big is the
over.
buffer?
Yeah, I think that's the question. Is that what's being asked? Is how big is the buffer?
Oh, I don't remember that off the top of my head. I'd have to go look that up and see what the buffer size is. Yeah, there's a limit of, I don't know how many thousand of RAS log entries, and it's a rolling buffer just like it always has been. So the oldest ones get rolled off as the new ones get shoved in, but I'd have to go look that up. If you can't find that, do let us know as well. Okay, so I'm going to go through SANNAV 2.1. Hopefully you all have seen SANNAV and used it at least a little bit by now. We've gone through SANNAV. You launched with SANNAV 1.11a, and you've done 2.0 now with this new release. It's going to be SANNAV 2.1. It's nothing. I'm just going to assume that you've seen it before because there's nothing earth-shattering in here. It's just it's SANNAV, and there's been some improvements and some enhancements and some added features and functionality that have gone in. But kind of this looks like kind of like a marketing slide, but this really is what they live by. Of if we're doing something in SANNAV, it needs to be something that helps you, and these are the buckets that they've kind of come up with, which really do make sense. So for 2.1, this kind of touches on some of the new things that are in here. So inventory and visualization, there's the new FOS 9.0 Web Tools launch with single sign-on. Under config operations, there's some new zoning features that are going in. That one is honestly the zoning is the kind of the trickiest thing to make sure that the flow is easy and understandable. So they continue to they get feedback from you guys or from the end users and from the field of things that work well and maybe things that don't work well, and so they continue to make tweaks on how that is, just to make it better and better over time, because they're honestly been doing a really good job of listening and reacting, which has been very nice. Of course, FOS EULA acceptance is is new in this 2.1 as well. Under monitoring, there's some new health summary dashboard features. Under troubleshooting, you can investigate any port at 2-second granularity for the last 2 hours. There's some other things in there. Under automation, there's some new REST interfaces that are in there for people that are doing the API. There's an OVA support, so if you want to install SANNAV, which you can, instead of doing a regular install on bare metal or into a VM, you can actually get the OVA and just fire it up within as a VM. You can just fire it up straight up like that. So there's another way to do that. So I'm not going to go through all of those. So we talked about fabric-wide lock support, and SANNAV is part of that. So he does participate in the fabric-wide lock support. So if you're trying to do zoning from SANNAV and somebody else somewhere else is doing zoning actively right now, it'll actually tell you it's in use. Please try again later. It's not, so that it keeps things from colliding and causing all sorts of weird problems that can happen. It's pretty rare, but it does happen sometimes. So we wanted to put as much protection in as possible. SANNAV 2.1 platform OS and migration support. So SANNAV 2.1 is supported as a VM and bare metal, but you do need to, if you're going to install it, it does need to be on top of Red Hat 778081 and CentOS 778081. If you want to install it as an OVA, you can. It has CentOS 8.0 packaged with the OVA, and you can install it on ESXi 6.7. And if you're going to do a migration of an existing SANNAV, you can do a full migration from 111X and 2.0 to SANNAV 2.1. All those are supported, so all the existing SANNAVs can be upgraded directly to 2.1. If you have an OVA, there's no migration path to SANNAV 2.1 because it's an OVA, and you can't migrate a non-OVA to an OVA because it's a different install. So Just a couple things to be aware of there. For EULA licensing and documentation, there is a new EULA for SANNAV 2.1. There's no changes to the SANNAV licensing model, so nothing in that realm is going to change. And there is a new standalone installation guide, which includes migration. So that's geared towards server admins that install SANNAV, but could be useful for you all because you would get the support calls if something went funny with that. And of course, there's the new web tools to support 9.0, which has the same look and feel as SANNAV. Unsupported and deprecated features. So we had been talking about a multi-node support, and that was deprecated in 2.0, and it's now unsupported in 2.1. And simply the reason for that is nobody was super interested in that yet. It is the capability is still there. So if we were to find some customer, it would have to be probably a very large customer that was interested in that. That's something we can definitely talk with them about. But at this point, we're just calling it as unsupported in 2.1 because there just wasn't a need for it yet. We kind of got a little bit ahead of ourselves, although we will need that probably eventually. And it's a good thing to be thinking forward about. And then the event management trap configuration is going to be deprecated in 2.1, and then it will be removed in 2.2. So the SANNAV 111 end of availability plan. So the plan and policies are available, so you can go and look at, if you go to the Broadcom.com support fiber channel networking EOL, you can go see what is EOL up there, and that's of course a live web page, so that changes. I didn't put anything in here because everything changes over time, so you can go up there and see what the end of availability is for that specific version, and for FOSS and for other things as well, of course. So that's it for the TOI, and we're running right up to the border. So this was only 2 hours, and if you and probably a lot of you are going to want more detailed training, which there's just no way to get it into 2 hours. Zafar and I went through this training, and it was 2.5 days of training to go through all of this with all of the full detail. And so if you want to advance your do more training, there's a lot of stuff available for free on the web. They've really been doing a good job of breaking it down into manageable chunks. So you could watch a chunk in 15, 20 minutes, and then go back to your regular job, and then come back later and continue on with it. So if you go onto the website, you can go look at the curriculum paths. There are a whole bunch of education up there in the Learning at Broadcom. So the 3 that we've got in red here are the ones that would be probably for you all. Probably these are going to be the deep technical ones. So there is a product update training for the Gen 7 switch. There's one for the FOSS 9.0, and there's one for SANNAV. So those are not lightweight courses. There's a lot of detail in there, and I would strongly suggest, especially the folks in support and engineering, to go and at least take a look at those and start working their way through them, because there is a lot more information in those things than I was able to squeeze into today. Of course, there's a lot of other sales and customer-facing materials that are available as well, kind of in the more outbound realm for those of you that are in sales or talking directly to customers. So there's a lot of stuff available up there to be able to go look at. And that gets to the end. There's my email address. There's Matt's email address. And of course, you've got the HPE SE alias that you all know and love and use regularly. That's also available for questions and things too. Do we have, I know we're right at the top of the hour. Does anybody have anything else that we need to talk about, or did I just run us out of time? Do we have time for any questions, or should we just...
Well, we don't have any in the question window there, and I don't see any in the chat either.
Okay.
I think we're good to wrap up right now. Anyone who does have any further questions, as you can see on the screen, you have our email addresses. You can mail us directly.
Absolutely. We're always happy to help.
And thank you, everyone, for attending.
Thank you, everybody.